Hi Guy, I'm Larei from AI Elephant.
Hi guys, I'm Leo.
Leo, we discuss the latest AI models every day, which LLM has achieved a new breakthrough. But have you ever considered this question? How do we truly know if an AI model is good? Or if it just fajui look-see good?
Well, usually we look at how fast it answers or how human-like the articles it writes are, but you mentioned the concept of agent. They don't just write, they have to use tools and handle multi-step tasks. Honestly, I'm a bit confused. How do you even evaluate an AI that can do so many things? Is it just about checking if the final result is correct?
You've hit the core point. Evaluation, a word that might sound a bit dry, is transforming from a post-mortem check into the core driving force of the entire agent AI field. In today's episode, we're going to explore why evaluation is so crucial and how we should systematically and reproducibly measure the true value of an AI agent. We must first answer the most basic question: why is evaluation so important? In essence, evaluation provides a systematic and reproducible way to quantitatively measure the performance of a model or agent. 7. This is absolutely not an optional step. It is the navigation system for our entire AI world.
A navigation system. That is a good analogy. But specifically, what is it navigating? Is it useful for researchers, or is it valuable for us, the general users?
It navigates the direction of the entire technological field. If you look at the historical benchmarks, from ImageNet to more recent ones like MMLU, they set clear goals for developers. 10. Evaluation helps us track performance, assess potential risks. 9. And ensure that the final model delivered to users is reliable and trustworthy. 5. Without evaluation, the development of AI would be blind. Let us look at how evaluation runs through the entire life cycle of AI development. It doesn't just happen at the end. It exists in 3 main stages: training, model selection, and final deployment.
That sounds like how we write an article. You don't just check for typos when you're done, you check the outline as you go, and then get feedback when it is finished. So, in AI training, what do they use to check as they go?
You got it! In the training stage, we use the loss function to optimize the model and validation loss to continuously track the training trajectory. 16. In the model selection stage, we need independent test sets to select the best model. And when the model is about to be deployed to customers or published in academia, evaluation must be held to the highest standard, trustworthy, standardized, and reproducible. Now, we focus on the core of today's topic, LLM agents. Why is the evaluation of agents much more complicated than traditional LLMs? Simply put, a traditional LLM is an indoor language expert. Its job is text in, text out.
What about the agent? Are they social beings? Do they have to go out and run errands?
Exactly. The agent is a complex social being. They live in a more complicated environment and must possess 4 key capabilities. First, tool usage. They need to call external tools to complete tasks. Second, planning. They must break down tasks and arrange steps. Third, multi-step reasoning. Tasks are not accomplished in a single shot. Fourth, memory. They need to remember what happened in the previous steps. So, evaluating an agent is not just about the final answer. It is about the rationality of tool invocation, the logic of the planning steps, and the state management capability across multiple time steps. To cope with this complexity, we categorize tasks. First, there are close-ended tasks, which have a limited answer space, such as multiple choice questions or yes and no questions.
Those are easy. You calculate the accuracy, or F1 score, and you know immediately if it is correct. This allows for highly automatic evaluation.
Right. But these tasks cover a very limited range of scenarios. More often, agents face open-ended tasks. Their output can basically be anything, with unlimited possibilities, 36, like asking an AI to tell a story or generate a piece of code.
Generating code or a math proof. Even though the format is not fixed, still has an objective, right or wrong, standard it either runs or it is provable. But telling a story, the quality of a story sounds like a subjective judgment, right?
That is a great distinction. If there is a clear standard or verification tool, we call it a verifiable task. But for things like the fluency, coherence, or redundancy of a story tasks, with no clear criteria, these are non-verifiable tasks. This is the hardest nut to crack in evaluation, and it leads to the core of our next chapter. For those non-verifiable open-ended tasks, we face two main evaluation methods. The first is the gold standard, human evaluation.
I know, human evaluation is the most reliable, but it is expensive and slow. Plus, every annotator has different standards, and sometimes the same person will disagree at different times. It is too human to be used at scale.
Therefore, the second method emerged, LLM as a judge. We use another powerful LLM, like GPT-4, to evaluate the output of a different agent. It is much cheaper and much more efficient.
Letting AI judge AI sounds a bit like a black box. Can its reliability really catch up to humans? And can it be hacked?
Your concern is valid. The reliability of the LLM judge is less than that of humans, and it carries the risk of being hacked. 63. Therefore, our recommendation is you must use small-scale human evaluation for cross-checking 50. This is essential to calibrate the AI judge's standards and ensure the fairness and transparency of the evaluation results. From the previous discussion, we can extract a core mindset model, which we call the evaluation. First, Mindset 64. It requires us to elevate evaluation from the last step of the development process to a critical mechanism that is continuous and drives decision-making.
So, evaluation first means that from the very beginning of designing an AI, we must think about how to measure it, instead of just building it first.
Absolutely correct. This requires us to do three things. First, embed evaluation metrics as optimization goals right from the start of training. Second, once training is complete, rely solely on benchmark results as the basis for model selection. And finally, and most importantly, we must build the evaluation system centered on trust and reproducibility. This is a commitment to society that the model we provide is reliable and the results are reproducible, thus guiding other developers towards safe and effective development. To summarize, the evaluation of LLM agents is essentially about measuring the multiple capabilities of an AI social being in a complex dynamic environment. It is not just about simple right or wrong judgments, it is the cornerstone of reliability, trustworthiness, and field progress. To ensure this, we offer three actionable recommendations. 1. Define task attributes. First, distinguish whether your task is close-ended or open-ended, verifiable, or non-verifiable. This is the starting point for choosing the evaluation method. 2. Balance cost and reliability for subjective tasks. Be bold in using LLM as a judge, but be sure to pair it with small-scale human evaluation for calibration and fairness. 3. Embrace the evaluation. First, mindset. Treat evaluation as part of the design, not a pre-delivery checklist. Only then can we build truly trustworthy AI agents.
After today's content, I feel that evaluation is no longer a dry page in the technical documentation, but a lighthouse that determines how far AI can go. Thank you, Larei, for providing this deep analysis. And thank you to all the developers who are dedicated to building safer and more reliable AI systems.